Okay everyone, welcome again to another video lecture series for differential calculus. So today's discussion will be on the chain rule. Okay, so this is a continuation of the process of differentiation for composite functions. In the previous video, you are presented with the basic forms of the differentiating algebraic functions. You were also presented in the second video of differentiating form of the function that are considered a product and a quotient. So today's discussion now will be on composite functions and the differentiation process for performing the derivative of composite functions. So let's try to consider first the definition. Now, if the function g is differentiable at x and the function f is differentiable at g of x, then the composite function is differentiable at x. And this is expressed using these symbols. You have f of g prime of x, meaning the derivative of the composite function f of g of x is equal to the derivative of f with respect to g of x times the derivative of g of x. Okay, so we'll be focusing on the symbols, and we'll be doing away with the other forms of the notation. We'll just be focusing on the symbols so that we could easily remember them as we go on with the examples. So again, perhaps to further illustrate how do we perform the definition, let's try to do this using a set of examples. So let's have the first number. We have f of x is equal to 2x plus 1 raised to 2. So in the definition of the chain rule, f of x here represents f of g of x. Now, our f of x would be the form of the base times square, the base raised to 2, while g of x represents x plus 1. Okay, so meaning this qualifies as a composite function, so its derivative would be of this form. And how to perform this derivative, it should go like this one. So first we try to copy the symbol. Now as for the answer here is, first we apply what we call the basic form of the power formula. Recall the power formula. If you have a base x raised to an exponent, a non-zero exponent, so what you do with that exponent is that you bring down that exponent beside your x, copy the base, you subtract 1 from the exponent. Actually, the form of the chain rule is almost the same, or the same actually with this one, except for one major difference. The major difference is that instead of having a single variable x as the base for your exponent, you have an expression instead. But the process is still the same. So meaning, doing the same for this expression, we write down the derivative of the composite function as, that would be 2. You bring down 2, you copy the base x plus 1, you subtract 2 minus 1 from the exponent, and the rest of the definition it says that you need to get the derivative of the inner function. Alright? And this would serve as the chain rule. Okay, so let's try to insert that. You have 2x plus 1. Again, you bring down 2 beside your expression, your base x plus 1. Copy the base. You subtract 1 from the exponent, 2 minus 1. Then you multiply that with let's try to copy the proper symbolism. So you multiply this with the derivative of the inner function, which is our base x plus 1. Alright? Okay, so again, now take note, I just have written down f prime of x as the derivative of x, which is equal to the derivative of the composite function. Okay, so what happens now here is that 2 minus 1 becomes 1, and since this is raised to 1, then it means that we could drop the exponent as raised to 1 only. So we need only to write x plus 1. Okay, so the next part would be getting the derivative of x plus 1. So the derivative of x would be 1. The derivative of 1 would be 0. So which means we could this entire expression here is equal to 1. So which means we could directly we could simply drop this entire expression here and leave 2 times x plus 1 as our final answer. We could also distribute 2x plus 1 to have 2x plus 2, or simply leave the answer as is. So this is already an acceptable answer, 2 times x plus 1. Now as for example number 2, we have g of x is equal to 1 over x squared plus 1. This is in the form of a quotient. Okay, so which means that we're going to apply the quotient rule for getting the derivative of g prime of x. The derivative of g of x, which is g prime of x. Okay, so let's try to write this first as g prime of x. So this should be equal to an expression equal to the quotient rule for applying the quotient rule for 1 over x squared plus 1. So let's try to have that one. Okay, so the quotient rule goes, recalling the quotient rule goes, 1 would be the high. We refer to 1 as the high. We refer to x squared plus 1 as the low. So meaning this becomes low. Okay, so low. Okay, so low, that becomes x squared plus 1 times the derivative of high, that is the derivative of 1, minus high times the derivative of low, the derivative of x squared plus 1, all over the square of low, the square of x squared plus 1. There. Okay, so let's try to insert this first. Okay, so again we have x squared plus 1 times the derivative of 1. Now the derivative of 1 is a constant, so the derivative of 1 is 0. So which means if this is 0, the entire expression here becomes 0. So basically this becomes 0, and meaning we could actually drop this out of the equation. But let's try to do this step by step. Perhaps on another line. So again, the derivative of 1 is 0. So meaning 0 times this expression becomes expression becomes 0, which means that we could drop that out of the solution. Okay, so let's try to copy this first. The derivative of the second, or the derivative of the low. Okay, as for this part of the solution now, since this is multiplied by -1, that means the result here would be multiplied by -1 later. But before that, we need to get the derivative first of the form x squared plus 1. So, replacing this part here by its derivative. Now, the derivative of x squared plus 1 at this point we apply the chain rule. The chain rule for this one is that this becomes 2 okay, so this becomes 2x 2 minus 1 plus, well, this becomes 0. Alright, let's try to write this in parentheses. So this would be replaced. Alright, now of course 2 minus 1 is 1, and x raised to 1 is simply x. Alright, now 2x plus 0, we could remove 0 here, and of course 2x times negative 1 is actually negative 2x. Alright, now so since we can no longer simplify this further, that means the final answer for getting the derivative of g of x is equal to this expression, negative 2x over x squared plus 1 then squared. Okay, so let's try to have the third example. Okay, so again, as you know by now, I am expecting that you already know how to convert any radical form or any root form into its corresponding rational exponents or expression with exponents that are of fraction form. But perhaps we could do this example once again. So we could replace first our cube root of x by an expression with so this becomes 1x squared raised to, the cube root is actually 1 raised to 3, 1 over 3. So the entire expression becomes 1 minus x squared raised to 1/3. Let's try to insert that one. This becomes 1/3, 1 over 3. Alright, now let's try now to apply the chain rule for this part. Okay, so that would be w prime, or the derivative of w of x. Now, recall that the chain rule says that you have to bring down the exponent besides the expression, copy the base, you subtract 1 from the exponent, then the next step is to get the derivative of the base. There. Now, of course, we have to get the derivative of the expression 1 minus x squared, and we have to get the difference between 1/3 and negative 1, 1/3 and 1. So 1/3 minus 1, that gives us 1/3 is smaller than 1, so that means 1/3 minus 1 is negative. That would be negative 2/3. Alright, so you have negative 2/3. Now, as for the derivative of 1 minus x squared, the derivative of 1 is 0, while the derivative of negative x squared is actually, let's try to write this one. Okay, so the derivative of negative x squared is actually negative 2x raised to 2 minus 1 is 1. So what is left now is that let's try to have this in parenthesis form. And insert that inside, replacing the derivative of 1 minus x squared. Alright. Now, can we simplify this further? Perhaps we could write it in a more simpler way, just like writing negative 2/3 x instead of having it like this one. We could also bring back the form of the radical in order to replace raised to negative this expression raised to negative 2/3, so that we could have a radical form. Doing that, we need to have a fraction form of this one, so that would be 1 over something 2/3 1 over. Now, getting the reciprocal means that we are the exponent negative 2/3 becomes 2/3 only. And as for this part x, we could replace 1 here by we could place x here as the numerator of our expression, so we'll just remove that part. And as for raised to 2/3, 1 minus x squared raised to 2/3, we could replace that with the cube root of raised to 2. Right. So that would be raised to 2/3. Okay, so finally we could leave actually the answer as is. Okay, so let me just clean the rest of the expression. So finally we have this form of the answer: negative 2/3 of x over cube root of 1 minus x squared, then square. Okay, so finally we have number 4. Fourth example, we have x plus 1 squared plus 2x plus 1 plus 1. Let's try to copy first. And m prime of x would be equal to. Now, for this part of the expression, again, using the chain rule, we bring down 2 beside our base x plus 1. We subtract 1 from 2, so this becomes raised to 1. And since this is only raised to 1, we could drop the symbol for 1 and simply express it as x plus 1 times, so meaning we need to multiply this with the, since this is chain rule, the derivative of the base x plus 1. Right? Okay, so I'll just leave it as is. Now, for the rest of the expression, we have 2 times x plus 1. This is supposed to be a quotient, but this 2 here is simply a constant. So what we can do here is simply get the derivative of 2 of x plus 1 multiplied by 2, then plus the derivative of 1. Alright, the derivative of 1. Okay, so let's try now to perform the actual derivative. Okay, so for this part, now derivative of x plus 1, derivative of 1 is 0. So this means this would drop out, while derivative of x is equal to 1. So this entire thing here becomes 1, and since this is 1 multiplied by the rest of the expression here, we could simply drop the symbol for 1. Okay, so next is, again, you have derivative of the same expression, which means this is 1. 1 times 2, that gives us 2. And finally, we have the derivative of 1 is 0. So this is 0, so which means we could drop this out of the equation. We could simplify this further by distributing 2 to x and 1. So this becomes 2x plus 2x, 2 times 1 becomes 2, and this becomes 2 plus 2 becomes 4. So finally, our answer for example number 4 would be 2x plus 4 as the derivative of the function m of x. Okay, so this concludes our discussion for chain rule.